Okay, this is the additional video for chapter 10. So hopefully you can have some idea on how you can solve some questions. Okay, for example, this is the cycloid. So let me rewrite the parametrics. That is x equal r, theta minus sine theta, and then y theta is, or let me write here, y of theta is r, or in here they are using the big R, but so let me change this to big R, but that's just the same R radius. Okay, so it doesn't matter. The first question, find the arc length. Okay, so before we continue, okay, I want you to try these questions by yourself, and then we can compare the results at the end of this additional video. Okay, you can pause the video and try, but if you want to know the results, let me show you. Okay, so first we can take the first derivative of each equations. R is just a constant, so this is 1 minus cos theta, and the derivative of y is r sine theta, because this is become 0, right? Okay, now what we are going to do, we are going to set up the square root of the x prime and plus y prime and then squared. Now we are going to have all this square root. So this is r squared and then 1 minus cos theta squared. Well, let me just write one by one. Okay. And then I can take this out. Okay. And then we can take this. Okay. And then the inside will be, so let me write here. So this will be r squared and then 1 minus 2 cos theta plus cos squared theta and then plus sine squared theta, right? Okay. Now we can solve this. This will be 1 or 2. Okay. This has become 1, right? 2 minus 2 cos theta, right? And r I will put here. Okay. Now we still need to remove this square root to make our calculations look nice, right? Okay, now to remove this, the idea that I have is we can take the 2 cos theta and make it into a half angle formula, right? Or if I have this cos theta, this will be cos squared theta over 2 and then minus sine squared theta over 2. Okay, so the idea is I want to cancel this, right? This 2, and then by doing this we can have the squared formations or squared equations that we can cancel with the square root. Okay, so probably this will be 1 minus 2 sine squared theta over 2. Okay, now I think we can take this into our equations. Okay, so let me write with light blue. So 2 minus 2 and then 1 minus 2 sine squared theta over 2. And then now look here, we can take this out, right? And then we have 4 sine squared theta over 2, which is 2 sine theta over 2. Or 2r, sorry. Okay, so that's uh, the result of this expression. So for the next part, if you want to calculate the arc length of cycloid, you can directly go to this expressions. Okay, these expressions. Okay, now we can compute the arc length. Okay, so compute the arc length. So arc length will be integrations from 0 to 2 pi from the information we have, right? This information from 0 to 2 pi. And then we can input the 2r sine theta over 2 and d theta. And then simply this is becomes, because r is just a constant, we are just calculating sine become cos or negative cos. So we will have negative cos theta over 2, but we need to divide by half, so we need to multiply by 2, right? Or we can take this as negative cos theta over 2, and then need to be divided by half. So we will have finally 4r negative cos theta over 2. This is evaluated from 0 to 2 pi. Or we can simply say that this is 8r. We can input the 0 and input the 2 pi. So 4r plus 4r, right? So 8r. And then the other questions is find the area under the cycloid above the x-axis for 0 to 2 pi. So if you maybe, let me just make it into that our new page here. So if you imagine the cycloid, it has like this, right? So if this is x-axis and this is y-axis, then we are just going to have integrations from 0 to 2 pi, right? That's our questions here. That is 0 to 2 pi or 2 pi r, right? Because this is the cycloid. You can remember the cycloid. This means the circumference of the circle, right? So this will be y dx. Okay. Now we can take these equations and then put the parametric. Okay, put the parametric inside y theta, and then dx over dt, and then dt. Okay. Okay. Now we can take this. Y theta become r 1 minus cos theta, and then dx over dt is r 1 minus cos theta, and then dt. Okay. Okay, let's have some calculations a little bit. So r squared going to be outside, factorize, and the inside will be precisely the 1 cos theta squared, so 1 minus 2 cos theta plus cos squared theta. Okay. Okay, and then we can do the double angle here. So we will have r squared 0 to 2 pi, and then 1 minus 2 cos theta plus half plus cos 2 theta over 2, and then d theta. Okay, and then we can integrate. This will be theta minus 2 sine theta, and then plus half theta, and then this will be plus sine theta over 4, and then plug in 0 to 2 pi. This will result r squared. All the sign will be 0, and then this will be just 2 pi plus pi, or 3 pi r squared. That's the area. Okay, it's B for B. Area under the cycloid above the x-axis for 0 to 2 pi. Okay, find the volume of solid generated by a volume region in B about x-axis. Oh, this is not really our case for now, okay? Because I think we don't really explore much in our course so far about volume, so we can just skip the number C, okay? Just skip number C. Okay, that's the cycloid. Okay. The other questions that I want to illustrate is the polar, okay, the polar equations. So it's asking the area inside the this is the lemniscate, okay, the lemniscate, and this is just a circle. So first, you can imagine how it looks like, and then we can have some calculations. Okay, you can pause the video and try to solve it. Now I will solve this equation, solve this problem, and let's see the results, whether you have the same results or no. Okay, let's just take the picture first. Let's draw what this looks like. So first, let me draw the circle. Okay. And then the lemniscate will be on probably here. Okay, probably like that. Okay. So it's a circle with a radius 1, and then the lemniscate with the outer here is equal to 2. But the important point now is to find the intersections, which is on this point. At least one. Okay, at least one. Okay. So if you look on the questions, it's inside the lemniscate and also inside the circle, which is this, right? And because this is a symmetrical, we want just one area here, right? A1, because we can multiply by 4. That's the total area. Okay. Okay. Now first, we can evaluate the intersection first. What's the angle? What's the angle? So r squared is 2 cos 2 theta and r equal 1. So we can take the 2 cos 2 theta to be equal 1. So cos 2 theta is half. So from here we got that the theta is pi over 6, right? Okay. At least we got the pi over 6. It says other 3 point here, but for this calculation we don't really need, because we can take just one area and then multiply by 4. Okay. Now the area will be 4 times of 0 to pi over 6, and then we can plus the, so if you still not familiar with this, let me take the picture. Okay, so our area is like this and this, right? This is maybe not really. Let me make it really clear, really clear. So this is the circle, this is the x-axis, and then you have some slightly curve like that, right? Okay. Now if we slice this and then observe, we have this as the theta equal pi over 6, right? Okay. And we have theta equals 0. If we just take this area, this is area for circle, right? If you have circle, you have sector, right? Okay. And this area is for the lemniscate. Okay, lemniscate. Now the lemniscate is from pi over 6 and then to here, right? When theta is 0, which is cos pi over 2, or in our case here, this is theta equal pi over 4, right? So we will need to plus a1 and a2 if this is we can make it into a 2 area, right? So the area 1 is we take half and then r squared, but r is just a constant 1, so we just ignore 1, and then d theta, right? And then plus, let me make it bigger like that. So this is from pi over 6 to pi over 4 of half this is r squared, but r squared is just 2 cos 2 theta for lemniscate, so we can just put in 2 cos 2 theta d theta and then cancel that, and then we can evaluate. So we evaluate, this will be half theta, right? So we can take this and then half theta 0 pi over 6 and then plus, okay? Plus cos 2 theta becomes sine 2 theta divided by 2 pi over 6 to pi over 4. Okay. Now we can take this pi over 12, right? And this will be sine pi over 2 is 1, so half minus pi over 3 sine pi over 3 is half over square root of 3 divided by 2, so this will be okay, this will be that, okay, and multiply by 4, this will be pi over 3 plus 1 minus square root of 3. So 1 over 4, let me check one more time, okay? 1 over 4, okay. Sine theta minus okay, I think it seems it's okay, right? Oh, I think this is wrong. Not 2. This is already half. Okay, we already take into divide by 2. So this should be sine pi over 3. Oh, this should be 4. Okay, this should be 4, so this should be half, so this should be 2. Okay, sorry. Okay, that should be the correct answer. So this is the area that we want. Okay. Okay, so yeah, that's the additional video that I want to share with you, and I hope you're already familiar with if you want to separate some polar area. Okay, so, like this one. Okay. Maybe next time we can have another one video, I think, if we have if I have time to spare with the videos. If not, then please check your exercise, check your textbook if you have, or check your exercise. I have given some exercise for parametric, and maybe later for polar I will give you more questions. Okay.